Good morning, dear students. In last video, we have seen the solution till question number 11. Today, we will start with the solution of question number 12. As you can read, question number 12 says that the value of the left hand side should be equal to 1 minus x cube whole square. So, here we will start with left hand side. The given determinant left hand side is 1x x square 1x x square 1, right? If I can recall the formula of a cube minus b cube, then the formula of a cube minus b cube is a minus b bracket a square plus ab plus b square. So if I factorize 1 minus x cube as 1 minus x bracket 1 plus x square, then I can get 1 minus x cube, right? So is it possible to obtain 1 plus x square from the given determinant? If you will observe that if I add row 1 plus row 2 plus row 3, then I will get 1 plus x square, right? So here we will apply the property row 1 gives row 1 plus row 2 plus row 3, and we have first row as 1 plus x square. We can take this common out using the rule row 1 gives row 1 divided by 1 plus x square. As I am dividing row 1 by 1 plus x square, I should multiply that outside, right? So here we are left with 1 1 1 as our row 1. Now to obtain 0, maximum 0 will help us to expand our determinant easily. So I will try to get zeros by subtracting column 2 minus column 1 and also column 3 minus column 1. As you can see that in doing so, I am getting my second element and third element of row 1 0. Moreover, if I can take 1 minus x common outside from column 2 and column 3, if you can observe, 1 minus x square can be expanded as 1 minus x 1 plus x, and then second element, second column, if I take minus x common outside, then also I will get 1 minus x. So I am taking 1 minus x common from column 2 and column 3, right? So we are left with this determinant, right? So I got two factors of 1 minus x. If I multiply 1 minus x with one factor of 1 plus x square, then I will get 1 minus x cube, right? We are left with 1 minus x, and I will expand this determinant using row 1. Then the next factor that I will get will be 1 plus x square. If I again multiply 1 plus x square with 1 minus x, then I will get 1 minus x cube, right? So 1 minus x cube multiplied by 1 minus x cube will give me 1 minus x cube whole square, which is our right hand side, hence proved. Let's understand the 13th question where we are asked to prove this. We will start with left hand side. If you will observe right hand side carefully, then you want 1 plus a square plus b square. Is it possible to obtain 1 plus a square plus b square from the given determinant? Yes. If I multiply row 3 by b and add it in row 1, then you can see that minus b square plus 2b square will give me plus b square. Again, if I subtract row 2 minus a multiplied by row 3, then also minus a square plus 2a square will give me plus a square, right? So if I apply this property, r1 gives r1 plus b into r3 and r2 gives r2 minus a into r3, then I will have this result, right? You can clearly observe that row 1 and row 2 have 1 plus a square plus b square in common. So I will take common from row 1 and row 2, 1 plus a square plus b square. As I am having two factors, I will write it as 1 plus a square plus b square whole square. After taking common, you have two zeros present in that determinant, so you can easily expand it using row 1, and the answer of the expansion is 1 plus a square plus b square. Again, already we were having two factors of 1 plus a square plus b square. We got one more factor of a plus 1 plus a square plus b square, so multiplying will give me 1 plus a square plus b square whole cube, right? Let's start with 14th question, where we are asked to prove left hand side determinant is given and we need to prove the value of this determinant as 1 plus a square plus b square plus c square. So the first step that I will do is we'll take a common from row 1, b common from row 2 and c common from row 3. Yes, as I am taking common outside, I have to write a multiply by b multiply by c multiply by the determinant, right? Here a square plus 1 is divided by a, therefore the answer is a plus 1 by a. The same way b square plus 1 is divided by b, therefore answer is b plus 1 by b, and c square plus 1 is divided by c, therefore the answer is c plus 1 by c. Now we'll subtract row 2 minus row 1, right? So in subtracting row 2 minus row 1, clearly plus a and minus a will get cancelled out and we will be left with minus 1 by a. In next, second element will be b minus b will get cancelled out and we will be left with 1 by b, and third element c minus c will be 0. The same way, if I subtract row 3 minus row 1, then a minus a will get cancelled out and we'll left with minus 1 by a. B minus b will get cancelled out and we are left with 0, whereas c and minus c will get cancelled out and we will be left with 1 by c. Now the next step that I will do is I will multiply column 1 by a, column 2 by b and column 3 by c. As I am multiplying a, b and c, I have to divide outside a, b and c. As you can see, I am dividing a, b and c. So earlier a, b, c was already present, so a, b and c will cancel out with 1 by a, b and a, b, c, and we will left with 1, right? And inside the determinant we will have a square plus 1 b square c square minus 1 1 0 minus 1 0 1, right? Now you can expand using any row or any column, you know that rule, but here we are expanding using row 3, so we'll expand the determinant using row 3, and as you can see that the result is 1 plus a square plus b square plus c square, which is our right hand side, hence proved. Let's understand the 15th MCQ, where a square matrix of order 3 cross 3 is given, and we are supposed to find a value of determinant k into a, where k is any constant. As you can see that the given matrix is a square matrix of order 3 cross 3, so I will take a random matrix a1 b1 c1, a2 b2 c2, and a3 b3 c3. We are asked to multiply a constant k with a matrix A, that is a multiplication of a scalar with a matrix. This k will multiply with each and every element of matrix A. Now taking determinant will change my square brackets into determinant sign. Now if I want to take k common from row 1, row 2 and row 3, then I can take, as we have k common factor in each row. So I will take k common from row 1, k common from row 2 and k common from row 3. So as I am getting 3 constants outside, I will write k cube and determinant a1 b1 c1, a2 b2 c2, a3 b3 c3. But you can see that this is determinant a. So k into a determinant is k cube into a determinant. The correct option is C. Let's understand the 16th MCQ. Which one of the following is correct? Determinant is a square matrix. No, determinant is a real value, right? So determinant is a number associated to a matrix. This seems more correct, but it should be elaborated. It should be a square matrix, because matrix can be in rectangular form also. That is, the number of rows and number of columns can be different. So more precise correct option is C, where determinant is a number associated to a square matrix only, because matrix can be in rectangular form. So the precise answer is determinant is a number associated to a square matrix.